Okay, let's just get right to it. If you walk away from this explainer remembering only one thing, make it this. Treating AI agents as simple plug-and-play features is a recipe for absolute chaos. Agents are not features. They are systems. If you just slap an AI agent onto your existing infrastructure, cross your fingers and hope for the best without actually thinking about the underlying architecture, well, you're going to be in for a very rough awakening. Welcome to today's explainer. We are unpacking Microsoft's official training material for solution architects. Specifically, we're looking at their blueprint for predictable agent architectures. And the whole goal here is to help you design AI agents that do their jobs brilliantly, and most importantly, never, ever surprise you when they go live. Nobody likes a rogue AI, right? So here is our roadmap for today. We're going to see why agents are systems, figure out how to choose the right platform, and look at models and orchestration. Then we'll design our safety and escalation protocols and wrap things up with advanced tools, voice, and multi-agent systems. Part 1. Agents are systems, not features. Let's lay down the foundation and understand exactly why your earliest design choices carry so much weight. You know how in construction, a slightly off foundation means the whole house leans? It is the exact same thing here. Every single architectural decision you make in agent design compounds. Your early choices, like which language model you use or how you design your initial topics, they dictate literally everything downstream. Your audit posture, your reliability, your ultimate costs. Get these wrong in the design phase, and it is incredibly expensive and painful to fix once you are actually in production. Moving on to part 2, choosing the right platform. Let's talk about where we actually build these systems and what happens when we inevitably hit the ceiling of our tools. As an architect, you absolutely must understand what we call the platform ceiling. You need to know when Copilot Studio's visual, low-code environment is perfect, and when a project demands Azure AI Foundry's code-first approach. Just look at the auditing capabilities. Copilot Studio is phenomenal for citizen developers and business analysts. But if your project requires guaranteed data-level auditing for compliance, or you need to build custom machine learning pipelines, low-code just won't cut it. You have to graduate to AI Foundry. Section 3, Models and Orchestration. This is the framing of our house. Let's see how these systems actually route and process all that information. Selecting a model isn't just about picking the newest, smartest AI off the shelf. It's about matching the AI to your actual business requirements. Take standard NLU, or natural language understanding. It guarantees a fully deterministic, identical response every single time. If you're in a highly regulated industry, that exact repeatability is exactly what auditors demand. Now, generative models, they give you amazing conversational flexibility for open-ended questions, but you sacrifice that predictable exactness. And sitting right there in the middle, NLU Plus offers enhanced reasoning that is absolutely perfect for voice channels. And your model selection builds directly into how your agent orchestrates its next move. Think of classic orchestration like a train on tracks. It uses explicit, hard-coded keyword triggers. Highly predictable, super simple to trace and debug. Generative orchestration is more like a self-driving car. It dynamically routes tasks based on a natural language understanding of what the user wants. It is phenomenal for adapting to weird, evolving user requests. But because it's probabilistic, meaning it's calculating its best guess instead of following a strict rule, it is significantly harder to debug when things go off the rails. All right, Section 4, Designing Safety and Escalation. This is where we install the safety nets so our users never get trapped in a frustrating loop. Think of your topic design flow as the ultimate safety net for your users. A well-architected session begins with a start topic to set expectations, then smoothly routes the user to your regular business topics. If the AI gets confused by an unrecognized intent, it gracefully catches the error with a fallback topic. But ultimately, if the AI simply cannot resolve the issue, it relies on an escalation topic to hand things off to a human. Listen, I want to be super clear about this. Deploying a customer-facing agent without an escalation topic isn't just a minor oversight. It is a complete governance failure. Imagine being a customer trapped in an automated doom loop with literally no way to reach a human. It's infuriating. You cannot leave people stranded like that. You must design this architectural safety valve well before you go live, not when you're scrambling to fix things after an angry customer complaint. Finally, Section 5, Tools, Voice, and Multi-Agent. Time to look at the penthouse suite of our structure, featuring deep integrations and scaling up. So, picture this. You need to connect to a target system, but it has no API, no connector, and no structured data export. It's just a legacy user interface. Historically, traditional AI integration just hits a brick wall here. You're basically stuck, right? Well, the modern answer is computer use. This is a wild architectural pattern where the AI uses interface analysis to actually click buttons, enter text, and read screens exactly like you or I would. And the best part is how resilient it is. If that legacy app repositions a button or renames a field in an update, the AI just adapts on the fly. It saves you from having to completely rewrite fragile automation code every time there's a minor UI tweak. Then there's the Model Context Protocol, or MCP. This is a real game changer. Traditional connectors force you to hard code your tools ahead of time. MCP completely inverts that whole concept. It's a standardized interface that lets your agent dynamically query and discover a catalog of new tools at runtime. So your engineering team can add new capabilities behind the scenes, and your agent just discovers and uses them instantly. Zero redeployment required. Now, if you are taking all this to a voice channel, heads up, voice isn't just a switch you flip, it's a major architectural decision. You absolutely must use NLU Plus models to handle advanced audio context. You have to write short, spoken responses because people can't reread a spoken sentence. Your escalation needs to connect to a live telephony call, not a text chat queue. And crucially, your entire workflow has to function completely hands-free and screen-free. Let's talk scale. Single agent versus multi-agent. The trade-offs here are huge. A single agent gives you consistent permissions and one beautifully unified security boundary. It's much easier to manage. Multi-agent systems, on the other hand, literally multiply your failure surface area and massively increase your orchestration complexity. Honestly, they should only be used when tasks genuinely cross hard security boundaries, like separating protected health information from standard operational data, or when you need vastly different permission scopes. I love this rule of thumb from the material. Complexity should be earned by demonstrated need, not speculated by anticipated requirements. Don't over-engineer in Sprint 1. Always validate your simple single-agent architecture in the real world before you try to justify the heavy, tangled complexity of a multi-agent system. When you do finally build and scale out, your architectural toolbox essentially has three distinct types of agents. Operational agents, which are the doers, they execute workflows and take action. Analytical agents, which are the readers, they comb through heavy data to produce insights. And task agents, which generate drafts or summaries to augment a human. Task agents are specifically designed to keep a human in the loop for regulated decisions where you just can't allow full autonomous action. So, as we wrap up this explainer, I want to leave you with a question to challenge your own projects. Look at what you're living right now. Are your current AI implementations truly predictable systems, or are they just speculative features? Are you building chaotic add-ons, or are you architecting governed, reliable systems that won't surprise you in production? Think carefully about your foundational choices. Thanks so much for joining me today, and I'll catch you on the next explainer.